So you're probably looking at this and thinking, uh-oh, there's 3 equations, and there's 3 variables, and you might have looked at the answer and noticed that there's 3 answers, and I'm just going to write the answer right here. Okay, and we're going to make sure that we know how to get to the answer, but what's nice about having the answer here is if I do make a mistake in the middle, I don't have to finish the whole problem. I'll realize right away, oh, I got the x value wrong, so let me go back and find my mistake before I finish the entire problem. Okay, so there's my answer, right? And you'll notice there's an x, y, and z now, right? Usually we're just used to x and y, and we're just used to 2 equations, but now I'm looking for the value of x, y, and z. So how do I go about doing this using only the strategies I already have, which is graphing, substitution, and elimination? Okay. And elimination is really going to be our focus here, because what I can do is I can figure out how to eliminate one of these variables, leaving me with just a system of 2 equations, which I can then solve. So here's how I start. I look at these equations and I think, which of these variables is going to be easiest for me to just get rid of for a little bit, bring back later? And what I observe, I notice, oh look, here's a negative x and an x. That could work, right? I could eliminate the x using these 2 equations. Okay? But then I notice, oh man, look at this. This is beautiful. This y, this is going to be extremely easy to eliminate. Okay, look, I'm going to number these equations. 1, 2, and 3. Now, in a lot of steps, you're going to see me, I'm going to fully recopy the equation so you can really see my process. But if I were to actually do this on my own, I wouldn't necessarily recopy the equations every time I'm going to do it. Okay, but what I notice here, I notice that in equation 2 and 3, if I were to add these 2 equations together, the y would be eliminated, right? So I'm going to do that. And then let me just show you what I'm thinking ahead. I'm going to also do the same for equations 1 and 3. I notice again the y would be eliminated, right? Because these are opposites. And so then I would end up with 2 equations that only have an x and a z value. And that would be a system that I would know how to solve. Okay, so let me show you. So again, I'm going to, like I said, I'm going to sort of recopy as I go so that you can really see what I'm doing, but it's maybe like a little bit overkill, but you can, this way you can see easier. Okay, so why did I pick equations 2 and 3? Because I noticed that there was this opposite pair of coefficients that would cancel. Now, let's say I didn't have that, then I would have to, use some other strategy. Like for example, if I multiply this equation by 4, then I would have -4, this would be +4, they would cancel. So if I don't have this, it's not a deal breaker, but it just makes it easier. So look what happens now if I add these 2 equations. I get 4x plus 1x is 5x. This cancels, this is -5 plus 5, that's 0. 4, this is 4 minus 1, that's 3z. This is 19 minus 20, which is -1. Okay, now I'm going to do something similar, but this time I'm going to use equations 1 and 3. Why did I choose 1 and 3? Well, I notice again that they have this deal, right? This +5 and -5. I like that. That makes my life easier because something cancels out. I have -x plus x. Ooh, look, this cancels too. I got lucky. Okay, now I'll talk about what happens if I don't get lucky here. But look, these are opposites, they cancel. These are opposites, they cancel. This is -5 minus 1, -6z equals 2 minus 20 is -18. Oh hey, this is an equation with just one variable. I can solve that. So I now have a z value of 3. And look, the first thing I'm going to do is I'm going to go, wait, is that correct? Oh yeah, look, this is x, y, z. So yeah, I'm good. I got my first variable. Now, what's going to happen a lot of times is you're going to move things around and you're going to go to cancel that y, and this won't cancel, right? Like I just got lucky here that this canceled. So a lot of times you'll end up with something like, I don't know, 3x minus 6z equals negative 18, right? But then look what you'll have. You'll have an equation with x and z here, and an equation with x and z also right here. So then you could just take those two equations and use elimination to solve them, right? That would be a possibility, right? If you have an equation with x and z and an equation with x and z, you can use elimination to solve them just like you would with any system of two equations. So I might have had to multiply, but I would have solved, and I would have found the variable for either x or z. Okay? But now, once you find the value for either x or z, now look, life's easy. Okay? Here's z. Now, I can't plug z back into one of these because then I'll still have two variables, an x and a y. But look, I can plug z in here. Here I only have two variables, so if I replace one of them with a number, then I only have one variable. So look, I'm going to replace the z in this equation. 5x plus 3 times 3 equals negative 1. Let's see if that's correct. Yep, looks good. Okay, and now I have an x value and a z value, so I'm just going to pick any of these equations because look, there has three variables here, so if I plug in the value of 2, then I can just solve, right? So I'm going to choose, this bottom one just because I have like a nice simple x and z and a positive 5y is nice. So I'm going to plug in to equation 3 right here. I'm going to plug in x is negative 2 plus 5y, y is what I'm trying to figure out, minus z equals negative 20. Okay, I'm going to combine like terms. This is 5y minus 5. And y equals negative 3. Let's double check. That's good. Okay, so you give your answer and you give it in alphabetical order. So x first, then y, then z. And that's it.